All right, so now I'm going to go ahead and prove the identity. So to prove an identity, you want to use your basic identities. So we're going to go ahead and maybe potentially use one of these. You don't have to use all of them. With proving identities, there's always more than one way of doing it. So the one way I will show you here, that's one possible way of approaching this question. With identities, you just have to play around with it until you could prove each side is the same. So one thing I try to do when I prove identities is to rewrite everything in terms of primary ratios. So by primary ratios, I mean sine theta, cosine theta, and tan theta. So the three main primary ratios, you could try to rewrite everything in terms of those three. So as you can see here, the left-hand side is already written as primary ratios, but this one isn't. So we can go ahead and rewrite that. Cosecant theta is the same thing as 1 over sine theta, but we have a squared involved here. So you can go ahead and square everything in this equation, and that would be okay as long as you're doing it to everything on both sides. So 1 squared is actually just 1, so I'm actually going to write it as 1. So let's go ahead and plug that in here. So tan squared theta, cos squared theta, plus sine squared theta. Okay, so I'm going to go ahead and replace the cosecant squared theta with 1 over sine theta. So what will end up happening here is you're going to go ahead and divide by a fraction. So when you're dividing by a fraction, it's the same thing as multiplying by its reciprocal. So the reciprocal of 1 over sine squared theta is sine squared theta. So I'm going to go ahead and rewrite that. It's 2 sine squared theta. So as you can see here, we haven't been able to cancel anything out, so we have to take another approach here. So one approach you could take is go ahead and apply a quotient identity on the tan squared theta. So tan theta is equal to sine theta over cos theta. But if you want to make it squared, you just go ahead and square every component in that identity, and you can go ahead and replace that. So tan squared theta, I'm going to write that as sine squared theta over cos squared theta. And that's multiplied by cos theta from the initial equation plus the sine squared theta is equal to 2 sine squared theta. Now, as you can see here, when we actually apply the quotient identity, you'll see that cosine squared theta is actually common to both the top and the bottom here. So that will actually cancel out. So what I'm left with here is sine squared theta plus sine squared theta is equal to 2 sine squared theta. And as you can see here on the left-hand side, we actually have two like terms. We can combine those into one. So we get 2 sine squared theta. This is equal to 2 sine squared theta. So once you've actually proven that left-hand side is equal to right-hand side, you have completed your proof. So when you complete a proof, one thing I usually do is I just write a little bit of a square. And that's how you prove an identity using your reciprocal and quotient identities.